Welcome to our second virtual Cloud City meetup. We're back again in a pandemic-friendly format. I'm Charles Fitzgerald, along with Chris Kelly at the Zoom controls. We're the organizers. Chris and I are both technology enthusiasts and also somewhat irreverent angel investors in Seattle. I have to pronounce that very carefully and not say irrelevant. We're coming to you live and direct from Cloud City. That used to mean just Seattle, but in these extraordinary and unprecedented times, we've decoupled from geography, and now the capital city of the cloud is everywhere and anywhere. Our mission is to talk to today's leaders and tomorrow's pioneers pushing the technology frontier. Our format for today is a 45-minute conversation with Diego Oppenheimer, the CEO and co-founder of Algorithmia. Then we'll take 15 minutes and take your questions. To submit a question, please use the Zoom Q&A button. And in the interest of full disclosure, I am a small investor in Algorithmia. So Diego, thanks for joining us. Not sure what planet you're on there, but I want to dive right in. So your company Algorithmia helps put machine learning into production. I am super interested in what's happening on the ground with machine learning, not with the big tech companies, but in the real world, real companies that actually have IT departments. So the hope is to talk about what's working, what isn't, and maybe we start. Tell us a little bit about what Algorithmia provides, and then let's talk about what you're seeing with customers.
Great. So I'll talk a little. So I don't think I need to convince anybody that machine learning is the biggest kind of tectonic shift in technology that we're going to see in our lifetime. If I do have to convince you of that, then I suggest you
not Kubernetes.
And so when you start thinking about that, you kind of dive a little bit deeper into well, why, right? So, at the end of the day, what is machine learning doing? And when I think about machine learning, I call it, I focus a lot on boring machine learning. And what I call about boring machine learning is optimizations and decision-making that improve business processes, run businesses, move metrics for a business. Because that's, versus, the Skynet machine learning AI that most people want to talk about. So I'll focus on the boring stuff, but the boring stuff is what moves the needle for businesses. It's what organizations are seeing in terms of value, how they actually make their forecasting better, how they make their optimizations better, how they can make decision making, improve churn of customers. And so at the end of the day, this drives the bottom line of a business. So when you think about, we'd say, okay, that's the concept of what we address in machine learning. Well, what are some of the challenges of machine learning? So we're pretty conversant in the data world. And so my background's all in data and analytics. I spend a lot of time working on that. The ROI point for the BI, as a good example of this, right, was what I call the screen, the dashboard, right? So the tableaus, the domos, the lookers, that's where you get ROI. There's a person sitting in front of that screen. They're looking at data. They're being able to interpret the data, and they can make business decisions that are based on that data that hopefully move the needle for their business. And everything in the process of getting to that dashboard, the collection of data, the data engineering going into that, the data warehouses, everything that you build, the value prop, all lights up when there's a person that can actually make a decision around that data and move the business needle. So in the world of machine learning, where's the screen? Well, the screen is when actually integrated into a production application. That screen, right? I actually have my business decision systems, my business rule systems making automatic predictions? Can I make decisions automatically? Can I make optimizations? Can I make all of things, system to system conversations where you're actually using the machine learning components to actually drive that decision making that will make things like cost allocations, price optimizations, when to reach out to a customer. These are all automations. So when you think about that ROI point, it's when I actually get my business decision system or my business application actually running the ML is when I get the ROI. So again, all the data collection, the data labeling, the data training, the training of the models, everything, all of that lights up when I actually can integrate it into my business application or system.
So give us this BML, boring machine learning. Give us some examples of the kind of problems people are tackling.
Yeah. So a good example is like in fraud. Right? So looking for patterns from fraudulent transactions and, lighting up those things, saying, hey, this is an anomaly, right? This person's transactions, why are they sending, we work with a couple customers in anti-money laundering. Why is this person based out of the US, who's only done transactions in the US all the time, suddenly sending, some chunks of money to Belarus. Well, maybe they have a cousin in Belarus, but maybe
Do
that's
you need
something that's
machine learning to worry about Belarus from a
yeah,
money laundering
well,
perspective?
exactly. So that's kind of a good example of like, you're actually looking at, and so why is fraud important? Well, fraud, most banking transactions, most financial services systems, they will assign an X amount of a loss, expected loss, right? So they put it in their balance sheet. We're going to lose this amount of money to fraud, and they just deal with it. A good example of when you see this is whenever you've called your credit card and you got a weird transaction, you're like, I didn't do that transaction. In most cases, they'll investigate it, but for the most part, they write it off, right? But they already gave that money. It's not like they're going to go to the merchant and take that money back. So they're putting this on their balance sheet and saying, we're willing to do that. So now you have this like negative effect on your balance sheet around fraud that you can actually use machine learning to reduce to get to that point. And so now you're affecting that business metric. So that's a good example of what I call boring machine learning, that we're applying it to reduce a problem. I mean, at the end of the day, PayPal is the most famous story around this, which is they were just losing money hand over fist. And then when they figured out the fraud, they became, a huge growing business.
But
so
that was also almost 20 years ago. So what's gotten better is the learning techniques have gotten better.
So so I can talk about one of our customers. So Merck is doing drug discovery with machine learning. And what are they actually doing? Well, the fact is that you can simulate how proteins attach to themselves using ML models. And to be able to do drug discovery, you're trying to do that at hundreds, millions of times over and over again to kind of like cover the space and understand, oh, this is the thing that would work, or this is what doesn't work. I get to test all those things and do it very, very rapidly. And so what they're actually doing is saying, okay, well, can we actually build models that will do these kind of like interactions and throw out the data based on those interactions that puts us on a path to do drug discovery. And so, maybe it's not as boring as it sounds, but like, it's doing
this day and age, it's pretty cool.
Yeah, exactly.
And so vaccine box.
Yeah. So in life sciences, machine learning is using a ton on the drug discovery plays, a lot less at the medical trial because that's very manual still and you have to do all the verifications. But in terms of like the R&D components, so, for example, using neural nets to like look at chromatography in how like different proteins attach to each other. So you can actually train a whole bunch of models based on that. And now you can deploy them. You need to run them at scale. So what's the screen, right? Where's it coming? To get into production, I need my test battery system or my experimentation system to be able to call those models at that scale to go run those jobs. And I have a scientist on the other side of it who's just sending those jobs in. So that's kind of a business system that's getting transaction. Anomaly detection on networks, so how do I know if a device is going to fail? Or more importantly, how do I know if a device is doing something that shouldn't be doing? Like, why is there a lot of TCP IP traffic on this device at 4 a.m. in an area where everybody's sleeping? Like, so I'm a bank, I have 300,000, 400,000 devices, looking at the traffic and trying to analyze, hey, this might be something. It could be a leak or some device that's about to break. Super important if those are transaction systems. That's one place. The other one is, hey, there might be something wrong here. Why is this? Like, are they exiting data from our network? In the world of remote, like actually understanding all the devices connected and stuff. So that's another place where you're looking at the data that's going over traffic, analyzing it, understanding how that might be doing.
And there obviously are a ton of cybersecurity companies that claim to do that. Are people really building their own systems to do that, and if so, why?
The large companies are, right? So a lot of the large companies are at least looking at it either because it's specific to their business. So you can think about a manufacturer with a lot of devices and keeping control over those devices that are specific to them. In government, same thing, kind of sensors, and looking at that. So like we see a lot of defense using ML for either image analysis or kind of like network detections type stuff. So in some cases they go buy, in some cases they build it. But the fact is that when they go decide to build it, because they have the expertise to build the model, they have the data scientists, they still need to get that into production, into a system. And that's kind of where Algorithmia comes in, which is we help with that production. And like the way I like to think about it is you have a software development lifecycle, and then you had your whole BI analytics stack. Well, guess what? Now for ML, for the screen to exist, right? For like screening them out, you have to get it into the application. So how do we merge the world of machine learning and data analytics into the software development lifecycle? How do I use things like my CI/CD pipelines to deploy new models? How do I use my source code management systems? How do I use my optimization and like monitoring systems? And so that's what our platform does, is it brings in the world of ML into the DevOps perspective.
Right. And so part of the path to success is having the infrastructure that allows you to deploy and scale these models. A lot of this transcends the technology, and that's kind of the classic IT challenge is you've got to have methodology and governance and all that. Maybe talk a little bit about what you're seeing is that's making these ML projects that are successful. What are they doing over and above having some Algorithmia software?
Yeah. So why don't I talk about the not successful ones as the
Yeah,
contracts
those
here,
are
like,
fun.
right. So um, once you start, so the big, one of the biggest challenges is what we call stuck in the lab. So I built a model. I'm a data scientist, machine learning engineer. I got the data. I built a model. I can see it's going to affect the business metrics. This is going to be great, right? Like I'm actually going to go and I can, let's say I reduce churn or I got my price optimization. Great. How do I actually get that working inside my production system? Like, so it can't run off of my laptop. That's for sure. It can't run off of my little VM that I created in the cloud. Like I actually need to integrate it into the business application or system that I'm running to.
Right.
That is the biggest failure point that exists today in ML, because it's not being thought of. So it's kind of like how do you work backwards? Like instead of thinking, hey, how do I get to production? Okay, I need to get this level of backup recovery, this level of scale, this SLA, this blah, blah. So these are all the things that you need to like check boxes to be able to actually get into production that have nothing to do with the model you built if you have the best model on earth. So one of the biggest failure we see is like what I call the stuck in the lab problem, which is how do I go from like what I built and I think it's going to work and it's actually going to have it to, can I actually get this deployed in a real world system? So that's the biggest gap. And so the successful companies are thinking backwards. This is the application that needs to run this. Like I joke around and say, like, if I could tell you that I could find fraud with 100 monkeys in a room, you don't care if I'm using ML or not. Why would you? You're moving the business application. So you would just ask me, well, I just want to make sure that the 100 monkeys can, meet IT security and InfoSec and, and I can, do recovery and send them to. So when you start from the production system and you work backwards in terms of like what everything I need, and a lot of this is in IT. So like I talk about the disconnected teams being the second problem, stuck in the lab. Data science is coming in, machine learning coming in and be like, look, I got this thing that's awesome, right? And the DevOps team is like, great, are you going to wear a pager? No. Okay, well, can you integrate with our InfoSec requirements? No. Like what happens when this goes down? Like how are we going to get it back up again? So these are all things that are like completely reasonable for a DevOps crowd, SRE crowd to say, we have really strict things, especially in what I'd call kind of like restricted industries. Like I totally get that you're going to bring a ton of value to us, but like, how do we actually get backwards, from that? So that's the, that's kind of like one of the biggest challenges. And then you have like kind of like the more technical challenges, which is everybody wants to piece their own thing together. And then you have technical debt around that. And so the successful teams that I've seen in the ML space are thinking about what is the business metric that we're moving, right? And how we're going to go affect that. And then what are the conditions to be able to run inside that system? And then pushing down those requirements so that they're actually discussed before you even engage on like, let's go figure out if we can build an ML model to do X, Y, Z.
And are you seeing big bang waterfall project? Is this agile? Are people testing this stuff and then moving it into production? How do they actually get it done?
Yeah. So I mean, agile, it's interesting because like we all think about agile as being fast. Like I'll tell you right now that the data science process is 10 times faster. Mm-hmm. Like it's built into the integration. I mean, experimentation is part of it. Like, you gotta get it wrong. Yeah, you gotta get it. So you have to repeat. And also you have, the biggest concept difference here, and this is where IT crowds struggle with, we're dealing with probabilistic code, not deterministic code. Nothing can change in what you're structuring your system and everything can be wrong suddenly, i.e. a pandemic, right? In the system. So it's like, the black swan events are extremely common in the world of machine learning because your model skew, your data skews, change. If I had a model that was just recommending clothing and all the data I had was for the summer, you're going to show up with your parka and it's going to throw off the entire model.
And so how do people put guardrails around that? If, you have the 3 sigma outcome, the 4 sigma outcome.
Yeah. So you start thinking about it like you automate. So this is where like the principles of DevOps are so good for this, right? So if you think about what an IT organization really wants to focus on, they want to focus on speed, security, scale, or the good ones at least, right? Like that's a good thing to have those 3 S's in mind: speed, security, scale. And DevOps is about continuous deployment at high quality. So when you start actually applying these principles to the world of data science, we look at it and say, okay, we know we have to repeat this process, multiple deploys a day. We have to get new data. We have to retrain. So we can't do it manually. Like we just can't. Like there's just no way on earth we can do it. So we have to build automation for it. So how do you build the automation is kind of the core component, right? You say, okay, I can grab my model, I can grab new data, new drop of data, retrain, deploy that model, get it in production, monitor it in production, understand that something might be going south. So guardrails are like monitoring, understanding what's going on, understanding the system, being able to alert, put those things in, in a queue and say, okay, we need to go relook at this. But the most important thing is if you constrain a data science team to move at the speed, so that's your waterfall or agile question. If you constrain them to move at the speed that a normal application gets deployed at, by the time you get into production, your data, your model, your machine model will have decayed in value. Mm-hmm. Like, and you might actually not get any value. Like this is it's a decaying asset,
right?
And so there's a time to value that's super important to happen because you will like start losing efficiency on that. And so in the old world, again, financial services have been doing kind of like quant models. In insurance, you've been doing actuarial models. So like this is not like particularly new concepts of how do we use data to kind of do some predictions and optimizations. The speed at which it needs to happen is what's changing. So you can get these old concepts of, hey, this is how we would get a new model. So like the concept of actually building a model and deploying it into a mainframe, on a, once a year, like doesn't go anymore.
Are we gonna do mainframe jokes?
I mean, they're still existing.
Yeah.
Right. I mean, we've had to implement with some. We've had to do integrations with some of them, even in a new like cloud native world.
But how do you go from the stuck in the lab? Once you're in production, you're doing full CI/CD, you're updating the model. How do you make that initial leap? So I've got something I think works. It's sitting in the lab. The data scientists have played with it. How do I get that into the app, into the production system for the first time?
Yeah. So the first thing, so I like that you talked about, you said, hey, we can talk about technology. I call it the beeps and boops. Like we can talk about technology all you want, but it's a people process technology problem. And actually people process is actually where most of the complication happens.
Right. And this is the history of IT, right?
Correct. Exactly. And so what you need to think about is, okay, who are all the people involved? Right. So, this idea that a data science team can actually get a model in production on their own, which is how most companies are pushing on them, is just not reasonable.
Right.
So you have the companies who are approaching it and saying, okay, we're going to create hybrid teams. So the like modern tech companies, think about like the Ubers, the Twitters, they're building hybrid teams that kind of own their entire destiny in terms of like all the way, the infrastructure it's going to run on, the production system, the DevOps, like they're creating these hybrid teams and saying, okay, this thing is isolated enough that it gets integrated into the rest of our systems, but you own the entire stack.
But in the data science, people who own the models are part of that as well, I assume.
Correct. Yeah. So you got the ML engineers. So you think about like data scientists, ML engineers. There's a little bit of a difference. ML engineers are more software oriented than the data scientists. Data scientists are more statistical oriented. You have the DevOps crowd. You put some, there's a good reason to have product managers. I'm glad that, my product management hat will still have a job in the future. You combine these, you create these hybrid teams and they kind of own the stack end to end. In larger organizations, in like more traditional, like financial services, insurance companies, life sciences, that's not really reasonable because all the systems are intertwined. Like if you think about like a large bank, right? Like every system's tied to every system. There's massive investments. Like the IT teams have made massive investments on everything. They're highly regulated. So you will have these like, okay, I'm going to have a data scientist that can be applied to this area, but you have to get to a point where they're working together. Because like it's working together, there's handoffs. And so one of the big things that we do with our platform is say, we've actually have a platform that's very good for the IT crowd because they get to check all the boxes that they need to check. How do we actually deploy that? How do we scale it? How do we do reliability? How do we monitor it? How do we do security? Security being super important. How do we do governance? So that we make sure that like we know anything that's running. And once that's all set up, we can give that to the data science team and say, hey, we just created the highway for you to deploy models at scale. Right now, we've checked all the IT boxes. Like they're okay with this. Now you can move at your speed. So it's really about enabling. And again, you go back to the DevOps. The DevOps principles were really, let's give the application developers the speed that they want so that they can re-up, the apps that they're building and kind of do that and do it in a very, very high efficient way so that we can go through the cycle time. Data science teams are the fastest moving software teams we've ever seen.
And so what does cycle times look like? I mean, there's
It could be minutes.
Dev team doing what?
It could be minutes.
Yeah. Okay.
Like online learning, like as you're doing like clickstream analysis, like it's minutes as new models need to be deployed. You're literally like reacting to traffic.
So that, I mean, that transformation to a DevOps model is happening across the board, in theory on the application side. What's really unique about getting the ML models into those new systems, new applications?
Yeah, so it's not just code, it's data and code. It's data that's shifting. It's models that change in performance and the explosion of tooling. So there's a combination of those three is what needs to happen so that, so again, a lot of the DevOps principles are being, again, I'm obviously pretty biased because what the entire thing we preach is grab our platform, integrate it into your DevOps processes, get use of your DevOps processes with our platform. We bring ML into that. So I want to be clear on that. But
that is an easy solution to the question I just asked. So
it is an easy solution. But I'll give the gist of it around that is really about thinking like, how do we, we know that models are going to change in behavior. How do we know when and what they're doing? We know what models are going to have. We need an SLA. So a good example, the clearest example of this is you have an attention span of 7 seconds when you land on a website. So if I'm going to give you a recommendation of something on that website, if it doesn't show up in 7 seconds, I might as well not do it because that's your attention span. Mm-hmm. Right. And so you start working with these kind of like, kind of principles of like what the end goal is and working backwards. And you want to try to integrate that. And so why can't we just use the normal DevOps processes? Well, again, we're looking at things like different hardware components like CPUs and GPUs. Right. That's a good example of like a whole new world. And, we can go down the GPU, rabbit hole, but like the gist of it is we have 30 years of experience plus of dealing with CPUs and memory management and how CPUs work. GPUs is the Wild West. Yeah. Like we just don't have all the tooling around it. It's getting way better, but it's the Wild West. But GPUs, especially on things like neural nets, are showing like 60x, 100x improvement. So going back to that SLA problem, like if I need to actually get a response for a process or a system to system talking to each other, and I need to make sure that SLA is really low, like now I want to look at that acceleration on the different hardware components. So managing that becomes hard. So that's one aspect of it. How do I actually create, the guardrails for these data science teams, which are rarely deep in software engineering, great statistical minds.
That's kind of a business question too, right? I mean, how do you set the business alert of, hey, it's July and the model decided we're going to go buy parkas?
Yeah. Well, the data, the data there is where we want to be like, you want to be able to react to the system. So I'll give you an actual example of something that I thought was pretty interesting that happened. So we have a customer called Happy Money. It's a big fintech company in LA. They are, their tagline is you want to create a happy relationship between you and your personal money. So it helps people get out of debt and how they do loans and stuff like that. But what they're really doing is they actually help you look at your income statements and stuff like that. And then they get you loans with credit unions, if you need actually loans and how to pay it back. And so they actually do automated suggestions on how to pay back this loan, how much should you be taking out for a loan, how are you going to pay down credit and stuff like that. And they do this all in an automated way. It's really fantastic. I mean, the team's amazing. So what was their problem when that pandemic hit? So pandemic hit, they had something like $40 million in loans being requested in like 3 weeks. And so they needed, the backers of those loans are credit unions. And so and they're the processing arm for it. Mm-hmm. So they're doing the risk assessment. They're doing the you should give this loan or not. They're doing all that stuff. So one of the things that they were having a problem, they needed to go rev their models very quickly
Right.
to a whole new world.
Right.
Right. Like, and that would have taken them potentially up to 8 months, right, to do. And, obviously they had our platform and they were able to actually deploy a new model within 2 hours because all the processes for IT were done.
Right.
Start doing that, drain that backlog of loans, which directly related into a 25% month over month increase in revenue for that company.
That's
the
great.
effect of done well.
Right.
2 questions ago.
So the pandemic impact, there's been a lot of impact on IT projects. What are you seeing in terms of ML projects and how have people changed their priorities?
Yeah. So anything that has the tag of innovation lab or innovation is dead. Done. Like there's nothing there. Like greenfield projects,
line of business.
But if you can actually show a business metric moving, we actually have a survey. You can go to algorithmia.com. You can see the results of that. 40% increase in budgets for things that have a direct line of, what I call it, direct line to make money or lose money, or stop, or make you lose less money. And so that we're seeing budgets being increased, people investing more in it. But again, you start from the end. What's the business metric I'm going to move? And then I'll talk a little about all the technology, that matters for that.
So blue sky's out, back to bread and butter.
For now, I think blue sky is always going to be there. So there's a success rate around that. So I found one of the things that we found was really interesting is that you get going back to the boring ML comment, forecasting and optimizations is use case number one. It's the easiest use case. The highest success rate, lowest return on investment multiple, super big, but we're talking 2 to 4x.
Mm-hmm.
Right? Potentially, or maybe 1 to 3x, multiple. The next one is automated decision making, right? Risk goes up. So more of those projects go wrong. They don't work. They don't get implemented. But the kind of transformational nature, or kind of the ROI can be 3 to 6x.
Right. So if it does work.
Yeah, if it does work.
It's a more impressive outcome.
And then you go to the greenfield, whereas you've seen 100x. Brand new market gets created, brand new kind of whole new concept of it. The failure rate's 99%.
Right. So, it sounds like a classic risk reward curve.
Absolutely. And the organizations that actually succeed at the big ones are the ones who've actually moved pretty quickly through, let's attack the low hanging fruit. Let's figure out how to actually do ML, scale things. Let's actually move it. And this actually goes down to people, because then you get buy-in to go do the big risky investments. But there's a normal nature of you go hire an ML team or an AI team, and it's let's just go for the 100x without doing anything. And then the risk is super high, the failure rate is super high, and then getting buy-in inside an organization to go invest in that. It's well, you just spent last 2 years and $10 million, and you got nothing to show for it.
Yeah. So, it's interesting. There are a bunch of different roles, different decision makers inside these organizations. How do you think about selling ML infrastructure to the enterprise?
Yeah. So this is actually, again, we just did a survey, and it's so IT is super important in the decision-making process. They hold a lot of weight, and
especially for those critical line of business systems.
Exactly. And so one of the things that we've learned over time, we would usually be talking to data scientists and machine learning engineers and VPs of data science, and they're super important. They're the ones who need to get their stuff out, right? If the stuff doesn't get out and into production, there's no ROI for them, right? Their entire world is not showing any value to the organization. So they're the ones that usually are bringing it in. But it's very quickly becoming I need to get the IT team involved. I need to bring in my IT team. And that goes back to thinking about production first, which is a little bit of a, the normal movement in ML was let's experiment here and then we'll figure out how to get to production. That's the innovation world that just got killed in pandemic. The ones that are actually moving quickly are we think we can move this bottom line thing. This is what production looks like. This is the team that's going to go deliver it, which is the data science. We think we can do that.
Right. Yep. So, they're taking it seriously from the outset. Are there other red flags or signals you see for projects that don't work?
Not out specific to ML, probably little. The big ones, which everybody looks at, is do you have executive sponsorship?
Mhm.
Because a project of this nature without executive sponsorship is dead. But I mean, that could be everything from, changing a pixel to, deploying Kubernetes to ML. Like, it's not specific to ML.
God forbid you're deploying Kubernetes. I'm going to try not to connect that back to your room of 100 monkeys.
Yeah.
Okay.
um,
Well, let's change gears a little bit. So I want to play a game, overrated or underrated. The idea is I throw out a topic and you tell us whether you think it's overrated or underrated.
okay.
And I want to start with TikTok. So, I'm just, the coverage of TikTok over the last couple months has boggled my mind. All the English majors in Brooklyn and political scientists are writing about the algorithm with a capital A, seemingly all powerful, without equal in the world. Chinese government has cleverly played along and added it to their export control list as if it's a weapon system. So the TikTok algorithm, what is it, and overrated or underrated?
So I don't know what the TikTok algorithm is in sense
Right.
of like,
But
I don't think anybody
it's
does.
some kind of content recommendation.
Yeah, yeah.
Right?
So I think, if you made it in a pure play, so algorithms without data are worthless. In the same way that data without algorithms are worthless. So let's go look at the data, the data. So they have the data, you can divide it up and say they have content and they have engagement. Like what content's being engaged with, what content's not. I think their experience is really good. Like I think it's very engaging. They've managed to crack our lizard brain in terms of like we like clicking on things and seeing stuff moving.
Mm-hmm.
And the engagement model is very good. And we're essentially feeding that experience. Now, is this like something that nobody else can create? I would be skeptical about that, right? I mean, I think they nailed experience. I think the experience of I don't actually have it on my phone, so I'm just my entire, which I think is funny, like my entire interaction with TikTok is people re-forwarding their TikToks into Instagram stories, which is just a ripoff of it, like which is kind of funny. But I think the engagement model for a younger, kind of like like digital first, like population, they like that model. They're super engaged with it. They're not really interested in the Facebooks of it anymore. They're not really trying to read on Twitter either. And so the combination of video experience and the fact that like that person's engaged is feeding into an algorithm that actually can continue doing that engagement. Like you're essentially telling it what's engaging to you.
Yeah. Well, and they also have the advantage of having a ton of good content to choose from. So that
Right.
sounds like you're on the overrated camp and, great product, but maybe the algorithm's not gonna reset the geopolitical balance of power on the globe today.
I wouldn't bet on just the algorithm doing that. No,
Okay.
that would be like saying like Netflix. Everything about Netflix is the recommendation engine.
Mm-hmm.
Like it's good. Like you
Right.
watch stuff that you shouldn't be watching, that you wouldn't watch ever. It's surfacing content that you would never find in any way. But like Netflix is about the experience, the fact that I can go watch something at any given time.
I, as you may have guessed, am a little boggled by the fawning over the TikTok algorithm. Good, but
I don't know enough about it. They might have some crazy property. I'd just be a little bit doubtful. I think what they nailed is the experience, and that's all that matters.
Yeah. All right. Well, let me throw some other things at you and get your reaction. So GPT-3, overrated or underrated? And does it have enterprise use cases?
I absolutely think it has enterprise use cases. I think the possibilities, in terms of retrieval are super interesting. And I think it's the closest that we're getting to, true AI, but it is retrieval at the end of the day. So I think there's still a gap. Like, is this like, like the cusp of, singularity because we have GDP3? No.
No?
Is it a huge advancement of where we are today? Absolutely. And I think it's particularly interesting. I think there's a lot of fun use cases around it. I think it's the ability to build quick apps, the ability to do that question and answering in a really like effective way is pretty, but it has a lot of limitations. It's just retrieval, which is like particularly fantastic at.
Mm-hmm. And it's the corpus is, I don't know what percentage of the internet, but
yeah, it's like, I mean, it's that, but you can actually, it's funny because like, if you start asking it questions about like ads and like stores, Like it's retrieving like information from like, a couple of years ago from the internet, like
Yeah.
addresses and stuff like that. But it's cool. Like the stuff, like would I go build an entire business based on GTP3? Probably not. But like that is definitely a huge leap forward
Yeah.
in terms of where we were.
I have all these half-written blog posts. So I'm hoping to get access and use it to finish a bunch of them.
Well, it sounds like you're able to buy it from Microsoft soon.
Yeah. Speaking of the singularity, so artificial general intelligence, should we be losing more sleep or less sleep?
We're pretty far out.
Yeah.
I mean, the state of the art is still like, middle school human.
Okay. So
Maybe
Elon is
before that.
maybe overly worried.
Yeah, he might have access stuff to that I don't see, right? As I said, I focus on boring ML, so like
BML.
He's looking at the fantastic ML.
All right. Last question on the sort of the AI buzzwords, and this is less than overrated, underrated, but everybody talks about democratizing AI. What the hell does that mean?
So I think the way I think about, like, can you take advantage of these optimizations in decision making as an organization? So I think it's an existential threat to every business to not look at ML. And you don't really need to look farther than our locality, right? Amazon's injected ML into every single part of their business, and the ability to make quick decisions, optimize, and collect data has allowed them to, essentially, win in pretty much anything that they've, I focus a lot on the kind of let's think not AWS, but the other Amazon business, the marketplace
chains and logistics.
Yeah, supply chain, pricing, right. Advertising, like ML is everywhere, everywhere inside that. And it's such a clear advantage, right? Where it has now become an existential threat to other organizations, where it's like, you're either going to apply ML to optimize on yourself, on your business, and do automated decision making, or you're going to lose, right? And so why does democratization matter? Well, it's better for all of us if multiple people win.
I'm just wondering who's out there crusading for AI elitism and saying,
no,
we're going to keep it for ourselves.
So being able to do it. Now, the question is, the interesting thing of this is, like, the MLs, from a particular business, right? Like, their fastest path to ML is their own data, right? So like, let's think about, think about, Oracle's that has the largest data set of business applications in the world. Individual companies have all their data in Oracle. Keep your comment to yourself on Oracle. That's real, right? That's all my business decisions, my ERP decisions, my HCM systems. Like, this is all real data that I can take advantage of. For me, democratizing ML is being able to apply ML to that. Because if I can actually apply optimization and decision making
as opposed to trying to buy TikTok.
You're gonna drive me into, like, that's where, I think you can see, like, that's the advantage. So the democratization is being able to say, can I actually do with ML the optimizations, and the decision making with my business data that other companies can do? That, to me, is what democratization. So I don't think it's undersold. I think I think it's completely undersold.
I'm trying to figure out who the anti-democratic forces are around AI, but we'll pursue that later. Another question. So Cloud Twitter loves to have religious debates about hybrid cloud versus multi-cloud versus cloud. I'm curious what you're seeing with ML and to what degree it's driving hybrid deployments and or multi-cloud deployments.
Yeah, so it's a data gravity problem, and not because of the cost of data, but because of the conditions around data. So there's three things that matter: cost, right, where it is, right, and how I need to move it; governance, law, GDPR, region, location, stuff like that, and then latency to, well, so I have four. So like latency, like in terms of like how quickly I can access that data and do that.
What the fourth one cycle looks like. Yeah,
and then fourth one is risk or privacy of that data. You can put that into like that. So why we see the hybrid movement. In a lot of cases, you just have PII or very, very sensitive transaction systems that, the government, the life sciences, they have them on-prem and they're not moving them anytime soon. It's more of a pain in the
But
ass.
it's a function of that just happens to be where the system is, so that's where we have to go to do the processing, or
Yeah, so
are there real reasons not to take it to the cloud, right? Is it inertia or is it?
it's a little bit of everything, right? It's a what's the advantage of moving it, right? To the risk. It's a risk reward, right? Like I have my own data center, I have everything locked down, I have my PII, I have my transaction systems there. Doing a hop outside of a network, A, is slower, B, introduces all these risks. So that's one thing. There's a increasing legal demands or compliance demands around not relying on one cloud provider. So especially the big banks, right? Like they might need to use Azure in Europe and AWS in the US, or be able to show regulator strategy that they have a backup to one or the other, within those. And so pretty much every enterprise that we talk to, there might be a little bit of confirmation bias there, but every enterprise that we talk to has a 2-1-3-1 strategy. 2 clouds, 1 on-prem, 3 clouds, 1 on-prem. And it's not because everybody will talk about optionality and lock-in. It's much less about that. It's more about where the systems exist, right? Where are the systems that I need to go run this stuff in, and why, and they were built there for XYZ reason. So there's a telecom provider that we work with that has literally their entire retail network is an on-prem data center network. Their customer-facing internet presence is all in Azure, and all their internal build systems are in AWS. And so when you look at that organization, and they're not moving anywhere. I mean, they're just moving stuff around. They're already in that situation, and ML needs to apply to all of it. So they're looking for places where they can actually get just a general level of consistency between those.
Makes
and
sense.
That's a pretty common. Yeah.
I think the best characterization is, people don't set out to become multi-cloud. They just kind of wake up and realize that's where they've become.
Yeah.
Right,
there's regulatory stuff. Regulatory stuff is being pushed pretty hard on that. And and then there's a cost thing. Like in ML is expensive computationally. And the reality is if you can actually run, there's a lot of blog posts about this, but if you could run your GPUs effectively, buying a whole bunch of GPUs and putting them on-prem is way cheaper than running them.
Markup's pretty high there. All right, let's take some better questions from the audience. So first question, do you see differences in adoption by industry? For example, I focus on telco and ML applications, seems pretty rare. What's an easy way to get these large applications started adopting ML? I'm thinking you need quick, easy wins and build from there.
Yeah, so I think so we actually see a ton of ML in telco. So that's actually surprising. We see everything from network optimizations to, again, it kind of, you have to think about where in that space, right? Like telcos have huge, have huge sales teams, huge marketing teams. They use ML, right? So applications in telco come through that. I think the quick and easy wins from my perspective, which I love that approach, by the way. I think that's exactly the way to think about it, is where can I look for forecasting and optimization problems. Forecasting and optimization problems are the ones that have the highest success rate. They're easy to get to, and you can actually show value very quickly. So in a telco world, that could be, think of it, customer support. Can we route customer support? Can we help agents provide, better topics to discussion? Can we, when you get on the phone, offer them something else other than, restart your modem? To make them a little bit happier, to increase.
I had that experience this morning with Congress.
Yeah, and so I think the question here is, can you get these use cases where you can focus on that and actually show that success? I think that's absolutely there. But honestly, telco is a big one. We see a lot of ML in telco.
So what kind of success metrics do you see people looking at in telco or beyond telco? So better customer service is an obvious one.
So I have a cheating answer, and then I have so we literally have a KPIs for measuring ML success white paper on algorithmia.com. So you can go download the white paper and read it there. But so the big ones are, the way we look at it is, how do you look at success for the what is the value that you got out of that model? So can you actually measure the business movement? we increase sales, we decrease costs, whatever that is. So that's like the one. Time to that is the other metric that we look at. Because if it took you $10 million and 2 years to get a 200K improvement, it's a pretty bad investment, right? And so time to value, the actual improvement that you get it, cost to get there. And then you start looking at kind of like KPIs internally, which is, can I do this in a repeatable way? Have I been able to repeat it? What's the maintenance cost over time? So these are kind of like flow down KPIs that we look at. But the biggest one is like, can you actually tie your ML effort to a business metric moving?
Okay, well, sounds like there's some more telcos you need to go sell out there.
Yeah.
Next question, and we haven't talked about Facebook, so this will be an opportunity. If machine learning is so great, why did Facebook keep showing me register to vote ads, even though I'm not a US citizen and used Facebook from Australia for a decade before moving to the US?
I think everybody was getting
David
them.
Griffin.
Yeah, I think everybody was getting them, to be honest. Like, so there's also a question of like, what's the affordability? Like, do you need to be precise? Like and that's an interesting thing.
Yeah, in this case, they may have wanted to just turn the dial to 100 and not have any precision.
And what's the risk of getting, so like there's a bunch of ML cases where the risk of getting something wrong is important, right? If I'm using it.
The risk here is David is annoyed. So the risk here is David is annoyed.
Yeah, but like is David gonna stop using Facebook because of that?
Well, I'm a little surprised to hear he's still using it. But
and then, I mean, here's another example. Like you buy everybody jokes about this, but you buy a barbecue on Amazon and suddenly you get recommendations for more barbecues. It's like, well, I already have a barbecue. I don't need another one.
Yeah.
And if I do need another one, I'm pretty pissed at the first barbecue I bought.
Yeah. Why didn't you show me that recommendation?
Right. And so I think, but again, what's the affordability here? Well, the affordability is super high. Like, you're not pissed about it. Like, it's whatever. You're kind of like making fun of it, but it's not really like changing anything. Like the problem there is like, well, did they miss an opportunity for recommending something that you would actually buy?
Yeah.
Right. But the risk is
I
really,
agree with you. The downside risk is
that changes from ML use case to ML use case. And so that actually goes into that KPI of saying like, well, what is the risk of getting this wrong? Well, getting providing a loan to the wrong person has a much higher risk than telling me that I should buy another barbecue.
Bothering David to vote. All right, next question on data gravity. What do you think about using GCP's BigQuery Omni that lets you query across data stores and across locations, on-prem, other hyperscalers? Might be too early yet to know. This was just announced in July by GCP.
Yeah, so I'm not super familiar. So my comments would be kind of a little bit out of out of touch. I'm not super familiar with it. I mean, we look at how the big data warehouses are being built and how they're getting feeds from everywhere, and I still am under the impression that more data is better as long as it's good data. So the more that you can actually go across, you can look at tie these things together, that will become important. If it's really about just like co-location of the data around that, then I think the biggest thing that Google is doing in this particular is Anthos. So I think Anthos.
Yeah, think of this is Anthos for data.
Yeah,
they're going to provide a middleware layer that spans multiple clouds and on-prem, and it's all going to work magically.
Yeah, so I think it's going to be in the proof, right, around that and looking at it. I think the data gravity, that will be there's a reason why they're doing it, right? It'll be, I don't know if it will be just solved, but that's exactly kind of like one of the problems, which is in a lot of cases you want to move it. There's another interesting thing that I think is tied to this. So I'm not going to comment specifically on BigQuery, but like there's a lot of systems that exist today that you want to power ML with, you want to power with ML, but you're not going to go tear apart the entire system. So think about these legacy systems that can't even connect to an API.
So we're back to the mainframe again?
Not mainframe, but maybe in between, right? Mainframe and so I have a traditional application that that doesn't, I'm not going to go, or I can't allow it to go have a network connection or going to go connect to an API. So how do I enable ML for that? Well, I can redeploy that entire application. That's one way of doing it. And that's not usually a good way. The other one is actually modifying directly the data source system under it, right? So I can actually do is say, well, when data's coming into this transaction system, I'm actually going to go behind the scenes. I'm going to go produce ML on it. And then I'm just going to add new data into that system, and that application just thinks it's still talking to its own data store. That's a pattern we see commonly, especially
Give us an example of what kind of systems have those.
older transaction systems inside banks is a pretty good one on that one, right? Where these things are rock solid. Like you would never, like if you come in and say, hey, I want to modernize this, make it cloud native, put it in Kubernetes, they will laugh you out the door. Like, are you kidding me? Like this thing has like 100 nines of uptime. I'm exaggerating, obviously. And like, it is rock solid over the last 20 years. We're not touching that. But these are the systems that are actually driving like, those banks. And so, the software principle of like, if it's not broken, don't fix it, like stands strong still today. Like modernization just for the modernization is a terrible idea.
Mm-hmm. A lot of stuff to do on that front. All right. Well, that's all we've got for questions right now. Anything you'd leave people with in terms of the nirvana path for ML?
Crawl, walk, run.
Okay.
Yeah. Focus on the business application. Focus on the result. Focus on how you can move it. There's just like so much goodness that flows down. You get a good result, you start showing it, you get more investment, you convince the authorities inside your team to invest more in it. You can actually build wider, bigger, more systems. And we see this play out all the time in ML. So we actually
that virtuous cycle.
Exactly. Focus really on where you can move the metric really quickly, and kind of get that quick because you'll get it out faster, and it'll show results.
Cool. All right. Well, that's super useful. Thanks for joining us. Couple closing items. Please go to feedback.cloudcitymeetup.com right now and let us know what you thought. We're still kind of tuning this format, and we'd love to hear any ideas for logistics or other speakers that we should go get. We should have a recording of this session up on cloudcitymeetup.com in the next few days. So if you want to check any jokes or anything, it'll be there. We're working on another installment for early December. It's not quite finalized yet, but I think we're going to have a great guest then. So keep an eye out for announcements on our next scheduled session. Thanks for joining us, and we'll give you a few minutes before you all dash off to your next Zoom call.